This video is for lesson 7-8, using radicals to solve quadratic equations. Back in chapter 6, we learned a process called completing the square, where we were able to take a trinomial that was not a perfect square trinomial, and by changing it into a perfect square trinomial, we could factor it. And that allowed us to do a variety of things, like solve an equation. We can use completing the square again to derive the quadratic formula. And with the quadratic formula, we can solve any quadratic equation. So first, let's review how to use completing the square. We'll use completing the square to solve this quadratic equation, which is in standard form. So the x squared is first, then the x, then the constant term. There's a 0 on the right side. Completing the square is a lot easier when the leading coefficient is a 1. So first, let's divide everything by 3. We get x squared plus 10/3 x plus 2/3. And 0 divided by 3 is still 0. Now, in completing the square, we would take half of the coefficient of the x term and then square it, and that would tell us what we wanted the constant term to be. We can make our work a little bit easier if we first move any existing constant term over to the right side to get it out of the way. I'm going to subtract the 2/3. So we have x squared plus 10/3 x is equal to negative 2/3. I'm leaving a blank spot here on purpose because I want to fill this in with the correct constant term. To find it, take half of the coefficient of x. So half of 10/3 is 5/3. Then square the 5/3. That makes 25/9. That's the constant term we would like to have for a trinomial that has 10/3 as its middle term. So right in here, add 25/9. And on the right side to compensate. The reason for doing that is so that this trinomial becomes a perfect square trinomial, and it will factor as x plus 5/3. On the right side, negative 2/3 plus 25/9 makes 19/9. Now we can remove the exponent of 2 by doing the square root on both sides. So on the left side, we have x plus 5/3, and on the right side, the positive and negative square root of 19/9. By the way, while the square root of 19 doesn't work out to anything nice, the square root of 9 in the denominator is just 3. So this is equivalent to plus or minus the square root of 19 all over 3. Finally, we can subtract the 5/3 to get the letter x alone on the left side. So we have negative 5/3 plus or minus the square root of 19/3. This contains both answers to our quadratic equation written in the compact form that uses the plus-minus sign. We can find the first answer by evaluating this using a plus sign, get the other answer by typing it in the calculator, but use the minus sign. We solved a specific quadratic equation that had numbers for a, b, and c by using completing the square. But we can make this a more powerful technique for us if we use completing the square on the general form that instead of numbers actually has variables a, b, and c. When we get all done, we will create a formula that goes x equals, and on the right side, instead of numbers such as negative 5/3 or the square root of 19/3, we will have our variables a, b, and c. With that formula, we can solve any quadratic formula for the rest of the school year. Let's do that in the next part of the notes. Let's start with a quadratic equation in standard form. Whoops, I see I made a typo on the note page. That should be bx right there. Sorry about that. And we'll follow through with the same completing the square process as we did before. Last time we divided by the leading coefficient of 3, This time the leading coefficient is a, so let's divide by a. We get x squared plus b over a x plus c over a is equal to 0 divided by a, which is still 0. Next, we subtracted our current constant term to move it to the right side. So we have x squared plus b over ax is equal to negative c over a. Again, I've left a blank spot right here. Now let's figure out what to put in the blank spot. We take half of the coefficient of the x term. So half of b over a is b over 2a. Do you remember what we then did with this? We square it. So b over 2a squared. That makes b squared over 4a squared. That goes in this blank spot. And over here to compensate. Now that we have this trinomial, let's factor it using the same parenthesis pattern. One set of parentheses squared. And in here we have our x plus b over 2a that we had figured out in that step right there. On the right side, let's write this down. Now take a look at the right-hand side. We have two fractions with adding in the middle. To actually add those together and create a single term, we need a common denominator. Let's multiply this by 4a and this by 4a. That way the fraction will have a common denominator of 4a squared and can be combined with this one over here. So we will get x plus b over 2a squared is equal to negative 4ac over 4a squared plus b squared over 4a squared. And now that we have common denominators, let's actually combine those numerators. So we have x plus b over 2a squared is equal to, when I add these together, I could write negative 4ac plus b squared, but instead I'm going to write it as b squared minus 4ac, all over our common denominator. Next up, let's take the square root. That gets us our x plus b over 2a. And on the right side, we have the plus and minus square root of b squared minus 4ac all over 4a squared. Finally, subtract the b over 2a, because that'll get the x alone. So we have negative b over 2a plus or minus. Now take a look at this square root right here. We can't really do much with the square root of the numerator, but the denominator is a perfect square. We can find the square root of 4a squared. It makes 2a. So we'll have the square root of b squared minus 4ac as our numerator, and in the bottom, a 2a. Finally, I want you to notice how there are two fractions, and they both have a common denominator of 2a. So we could rewrite this as x equals negative b plus or minus the square root of b squared minus 4ac, all divided by the common denominator of 2a. We have actually added the two fractions together by putting the numerators together and keeping the denominator 2a. This does show two answers because of the plus minus sign. This right here is called the quadratic formula. It is a way to solve an equation for x if you know numbers for a, b, and c. In Algebra 1 class, your teacher told you the quadratic formula and you used it to solve problems. But what you didn't do probably was actually derive it, actually see step by step where it comes from the original standard form equation. Okay, now that we've created the quadratic formula, let's use it. Let's say we want to solve this equation, which is in standard form, but with the quadratic formula. So first step, write out the formula. A is 3, B is the minus 10, C is the 2. So when it says negative B, we get 10, because B is negative 10. So negative B would be a regular 10, plus or minus the square root. Now we go B squared. Well, B is negative 10, so what is negative 10 squared? It's 100. Now we go minus 4 times A times C. Well, A is a 3 and C is a 2. This is all divided by 2 times A. Well, what's A? A is a 3, so what's 2 times 3? That's a 6. Okay, next step. Let's do some work inside the square root radical. Simplify it up. 4 times 3 makes 12, times 2 makes 24, so in there we have 100, take away 24. That's 76. And this is all over 6. Okay, at this point, we're ready to simplify in our radical as much as we can. Certainly, the nicest thing that could have happened is if the square root of 76 just made an integer. But that didn't happen here. Can we factor 76? Well, 76 is the same thing as 4 times 19. And we can take the square root of 4. So in the next step, we have 10 plus or minus 2 square root of 19. And that's all over 6. This reduces because 10 and 6 reduce, and so does 2 and 6. So 10 and 6 both divide by 2. We get 5 over 3 plus or minus. And then over here, 2 over 6 both divide by 2. We get 1 square root of 19 all over 3. Here are our two answers. Notice that those are identical to the answers that we got when we worked it out back here. The difference was we were doing the completing the square with all of the actual numbers. The second time we did the problem, we used the quadratic formula, and we just had to substitute values into the different places in the formula and then simplify it out. For most people, this is the easier way to do it, to use the quadratic formula. Let's summarize the lesson. We used our completing the square process from chapter 6 to create a formula that we can use to solve quadratic equations. Make sure the equation is in standard form. That allows you to figure out A, B, and C, and then make those substitutions into the quadratic equation. The quadratic formula, or some people call it quadratic equation, is this right here. If you write this down on the first several problems that you do, it eventually will lead you to memorizing it, and then you probably don't have to write it down anymore.